Alright, before we start, I'll recommend you to watch these videos first. If you're done, let's get into it. There's an important thing I forgot to show you in physics. For example, we know that m as mass has first derivative with respect to time is equals to 0 in closed system, which if we have S as closed system, then all mass here like m1, m2, and m3, they can get out from S or stay inside as definition of closed system. So here, to be precise, tell us about total mass inside the system, which equal to this equation if there is mass density, and the next one for charge has similar analog to mass as this equation, which Q here is total charge, and of course equals to 0 mean in closed system. To differ from mass and charge, I will denote for mass density as rho m and charge density as rho q. These two things relate to conserved quantity in integral form. So the question is, what about the differential form? Which that's why this is important thing in physics. To get started, let rho is density, maybe mass, charge, or etc. for Q quantity as total amount. The first derivative of total Q is equals to this first derivative of some integral, and here omega may be higher dimension coordinate system and time dependent. So we can rewrite as this, and coordinate xi here may be depend on time. Notice that we can denote the differentiation by definition of derivative as this, and here we need transformation from this omega prime related to t plus h here to this omega, and in previous video we get result as this, which can be calculated by the characteristic of Jacobian. So we get this result, and notice that this subtraction part, if we multiply it by 1 over h and we take limit, then it will relate to the first total derivative of rho with respect to time, which by partial differentiation chain rule, we will get this result, and the other term here will relate to this, and by limit, we will get the rho as this. Here we can use product rule that calls the result as this. And here, we know that in previous video as J or general current density. So we get another form of the integrand as this. Finally, this will equals to this integral, which S here is sort of Q density. And then we get this differential equation. For S is equals to 0, the equation will become as this, or known as continuity equation. And as result before, this relate to conservation of Q. Then for S is non-zero, the Q is non-conservative quantity. In other words, there is sort of Q that make Q increasing or decreasing, which is different for continuity equation that Q has stayed the same value along the system. Thanks for watching this video. I hope you enjoy this video. If you like this video, don't forget to share and subscribe. If you have any question, please drop comment below, and see you later.